The coral in the Great Barrier Reef, the largest coral reef in the world, has died off due to ocean acidification. So, what is ocean acidification, and how is it hurting our reefs? As the name suggests, ocean acidification refers to when the ocean acidifies. This occurs when a solution has hydrogen ions present, having been given from another substance. Those ions are then accepted into a base, which in the ocean's case is water. This forms hydronium, or H3O. For simplicity's sake, let's just remember that hydrogen ions cause a solution to become acidic. It all starts when carbon dioxide enters the atmosphere, often when fossil fuels are burned for energy in a process called combustion. Combustion usually has three things: a fuel, an oxidizer for that fuel to react with, and an exhaust. Coal is largely carbon-based, and during combustion, the carbon bonds with the oxidizer, forming carbon dioxide. This is our exhaust. Once carbon dioxide is created, it spreads throughout the atmosphere through a process called diffusion. We can see this in everyday life. Think about it. If you have a pot full of steam and you release the steam, that steam moves across the room, moving from an area of high density to the areas of low density throughout the room. This process allows carbon dioxide to travel all throughout the atmosphere, where much of it reaches the ocean. Now, water is a universal solvent, which basically just means that it can dissolve many substances. So the ocean takes on a lot of the atmospheric carbon, about 30%. This is called carbon sequestering. Once the carbon dioxide dissolves into the ocean, a flurry of chemical reactions happen. The carbon dioxide, or CO2, bonds with the water molecules, or H2O. This forms carbonic acid. The carbonic acid then breaks down into bicarbonate molecules and, importantly, hydrogen ions. Finally, the bicarbonate molecule breaks down into a carbonate molecule and two hydrogen ions. Since there's such an excess of carbon dioxide, the hydrogen ions greatly increase, making the water very acidic. Finally, we should mention a rule used in chemistry called Le Chatelier's principle. This principle states that if a chemical reaction is tilted one way, it will shift back the other way to try to balance itself out. You can think about this in a round of juggling. The left hand starts with 2 balls, and the right hand starts with 1. After the first juggle, the right hand can throw 2 balls back, while the left hand can only throw 1. We can apply Le Chatelier's principle to the third equation we were talking about. Because of all the excess hydrogen ions we've made throughout these ocean acidification reactions, the equation becomes shifted back towards bicarbonate. This in turn decreases the carbonate available, which is fundamental in developing coral reef structure, as they are composed of calcium carbonate. And that is how ocean acidification is affecting our coral reefs.